that is heavier. So towards the side that's heavier. For clarification, do an image search for balance scale. That's I would say it looks like this. Okay, let's do balance scale. Balance scale. Yep. Look, babe. If you were to understand my question, you would have got it. I got the question. I should. So, what I meant is I have to write it for new. Give me a new page. Let's cancel. Give me a new page. New page. Save as. We'll save. Test this guy. Now. A and A and A x equal A and A and A. That's so x and x is true, 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 or false, 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 false. Wait, this is true, true, true. False, 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 false. If we NAND it to any A, if A was true, false, true, false, or false, true, false, true, or true, 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 false, 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 So read and understand where I am going with this. Let's go to question. Our question says 12 coin balance scale, one of which is fake. All the 3 coins weigh the same, but the fake coin is different. Important test case before just this on its own. It flips twice out, it's not constant. What A is true stays true. If stays if. Table showing it's only be right if A itself was fixed at F the whole time as a general. And now you're X with it, not X. Oh my god. Oh my god. This is true, true, false, false. So true, true, false. It's never gonna be that. I'm getting it wrong all the way. And so it's so you're saying so you are saying A is true, false, A and A, which is A is true and false, equal TT true, false, false, false. Are you saying like this? It's going to be always false. I mean false and true. It's going to be false and true. It's going to be false and true. True, true. So, true, true. Oh my god. False C. So, this giving equal X equal in and A, false true. False true. Am I correct? False true. So to do that false true, NAND A, okay, X NAND, come on, for fuck's sake, NAND A, so I got false T false, true, true. Am I correct? Okay. This is y. So then they get if true, true. Now all equal y NAND y, which is true. So false. Now all NAND A if true, false, true, false, is always what? True. So let's read what he means. Now, so here's the actual x and x. Then the step result. The leg gives constant. The two-step. Different pairings give genuinely different outcomes. That's a sharp thing. Rather, is this the mismatch? This converse method here. Spot on. Let's try it. The full picture, and it lines exactly with very first answer to why. This is your expression. O y NAND y. This is your always false expression. Original submission had to try it the whole time. Usually there, but the one I chained it the way had it checks out nicely. Trace through with your own table this next time. So what you're saying is here, using only NAND without needing to using A NAND A. A NAND A. Okay, I'm doing this. I'm crushing it. Believe me, that's quick one. Quick one. Let's go back to the original one. We got A is true or false. A and A, and A, FT, which is checks that question right. So, okay, nope. You have 12 coins and a balance scale, one of which is fake. All the real coins weigh the same, but the fake coin weigh less than the rest. All the coins visually appear the same, and the difference in weight is imperceptible to your senses. Most three wings give a strategy that detects the fake coin. Note the scale in this problem is a scale with two dishes. That's his behavior. For clarification, do an image search for balance scale. So what do we do? For 3 times. Okay, how many? 12 coins. 12 over 3 is 4. So in order to test them all, we got to get them the 4. So if we get the 4, first 6, 6, how are we gonna know? If we put 6, 6, where it weighs more, what do we know? All the real coins weigh the same. The fake coin weighs less than the rest. So 6, 6, where do we find it less? Less goes down. We take the 6, 3, 3, less. So we have 3 left. We have 3 left. 3 left. How to weigh them down? Okay. Now 2, 1 here, 1 here. If equal, then the one out is fake. If less, if one is less, then it is the fake. I'd say this is, so let's write it down. So I got, give me more, add 1. No, for fuck's sake, give me 1. No, 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 no. Circle, back tools, plugin, journal, navigate view, presentation mode, show sidebar. Okay. What is this? Okay. I got by stroke. Should be by stroke. Be a stroke. Without delete stroke. Okay. Go back. So we'll put oh my god. Stroke. Fuck off. Stroke. God damn it, this pen. We'll put 6 in one side and 6 in the other. Then we'll put then take the way less, which goes up, because the weight is less will go up, and put 3 in side and 3 on the other. Now then the one that weigh less we're gonna put 1 into one side and 1 into the other. Oh my god. If both equal, then the one left outside is fake if one way less than it is the fake. Cool. In 3 steps. Okay. Check this out. Claude. Problem 4. And that's it for today's math. We didn't, oh my God. Why is, oh, it's still live. It's good. Nice. This actually works, and it is the clean version of this puzzle since you already know the fake is lighter, not heavier or lighter unknown, which is the harder classic version. Walking through your strategy, lighter contains the fake down to 6 candidates. Lighter side has the fake down to 3. That's why one side. If the scale balances, the leftover coin is fake. If it tips, the lighter side is fake. That's exactly 3 wings, and it correctly identifies the fake every time. The key insight you landed on splitting the suspect group roughly into thirds each round is the right move here. Each wing has 3 possible outcomes: left lighter, right lighter, balanced. So dividing by 3 each time makes full use of the information. Gives you 6, 3, 1. Done in exactly 3 steps. This is a correct, complete solution. Nice work reasoning through it independently. Okay. So I'm going to go back to the lecture and see if I have covered everything from today's lecture. So
the following content.
right.
So he won prizes for this. He won the highest prize in mathematics, the Fields Medal, as one of the great unsolved mysteries. So if you get out this Globe article here, on the handout, does everybody have this handout? You don't? We'll get it passed out. Somebody missing that handout up over there and over here? Done in the text. And it doesn't really matter which one you want to use, as long as you use one of the. What about P implies Q? It's true because Q is true, the definition. If P is true and Q is false, all right, Z, n greater than or equal to 2, send this truth table out here. It's true, false. And that's it. If they're different, then it's true. To be true. There's no proof that an axiom is true. And the idea is, and there you have an axiom that contradicts them.
Wait. Tape. lecture cover axioms. Did I miss that on today's readings? Or is it just another name? And it does cover axiom at timestamped. What's axiom and follow consistency right after. But here's the thing, the axiom topic itself isn't in chapter 1 of the reading propositions. It's covered in the complete course notes intro, chapter 2, patterns of proof, which discusses the axiomatic method and briefly mentions ZFC Frankel set theory as the modern foundation. Though the notes explicitly say you won't be working with ZFC directly in this course, it's just background context. So no, you didn't miss it in today's readings. If you are reading chapter 1, that reading covers propositions, logic notation, not axioms. Axioms live in the course notes. Chapter 2. If you want, I can pull the exact axioms section. So am I correct on where I stopped today? At where did I stop? Where did I stop at the problem set? The chapter 1 positions. Where did I stop? I think page 12. More notation, implies, so forth. Using quantifiers, order of quantifiers, rebels overdone, validity, satisfiability,